Light is something that we all see around us. Or is it something that helps us to see everything around? Wait a minute, can we even see light? And if we are going to have a discussion, what even is light? No need for any more confusion, as in today's video, we are going to dive into vast light beams and explore them, so hang right on. Before beginning this video, if you like the content that we post, and if you want to hear from us more, hit that red subscribe button, and press the bell icon to stay updated on our activities. First up, what is light? Books say that light is a form of energy that travels as waves, called wavelength. However, the ancient Greeks had a rather interesting theory regarding light. They believed that our eyes emitted rays of light, which reflected back after hitting a surface. This might have sounded pretty smart back in those days, but if you were to advocate this theory today, people might believe that you have gone nuts. So we will just stick to what the books say. Picking back from wavelengths, these also determine many of the properties of light, from its color to the way it reacts to different matter. The range of this wavelength also determines whether the light beams are short or long, in simple words, the light spectrum. And while we are at it, you should also know that light is not the actual name. Light is formally known as electromagnetic radiation. And all forms of light beams share three same properties. They travel at a constant speed, that is 3 times 10 to the power of 8 meters per second. They can all travel through vacuum, and as we said before, their wavelength defines their color. What is more interesting is that light can also behave as photons, or in simple words, particles and matter. This makes light to be countable quantity, just like the beads on a string. Quite intriguing, isn't it? One must also remember that no one definition of light can properly define the multi-faced experiences and explorations of light. Over the ages, as humans developed from the early primates and mammals, the retina in the eye, specifically the rods and cones, developed to receive wavelengths and sense them. These wavelengths are what we know in common words as the light. The maximum wavelength that a normal human can see is 700 nanometers, displaying the red color, and the least is 400 nanometer, which is violet. All the other colors we see are of varying wavelengths adjusting within this range. The most visible though, are the vibrio, violet, indigo, blue, green, yellow, orange, and red. And where else do we see this color combination the most? The rainbow. You may ask, why do we see only these colors and not others? Well, these colors are the most visible to the human eye due to the sensitivity of rods and cones present in the retina. However, most of the light spectrum falls outside of the 400 to 700 nanometers range, which is not visible to most human eyes. Although bees and dogs, and a few other animals have this ability to see light beyond the visible spectrum. Now, light has two main units of measurement: radiometry, consisting of measurement of light at all wavelengths, and photometry measures light with a wavelength weighted in comparison to a standardized level, or a model, of human brightness perception. Moreover, did you know, light exerts pressure? No, I'm not talking about the sunlight or the light from the car beams getting into your eyes. Light, as we already discussed before, is made up of photons, particle matter. So when light falls on any surface, the photons also hit the surface, transferring their momentum, and creating physical pressure in the process. This phenomenon had been deduced by Maxwell's equation, which states that light pressure is equal to the power of light beam divided by the speed of light. However, the magnitude of the speed of light makes this pressure negligible in everyday life. Only in laboratories and research facilities can this pressure be actually observed, mostly during some sort of research or study, or for show. The timeline on the study of light is equally interesting, beginning from the time of the Greeks, going through the time of the Arabian scholars and through ancient India, passing through the papers and inks of Descartes, Pierre Gassendi, Robert Hooke, and Faraday, and many other notable scientists, and undergoing such intense study, even today. We'll leave that timeline for another video, and bid you our wishes. We hope that you liked this video, and if you did, please like, share and comment without fail. See you in the next one.